This is problem number 60 out of the Halliday, Resnick, and Walker textbook. It reads, this is chapter 13, it reads, in figure 13-50, two satellites A and B are both mass 125 kilograms, are moving in a same circular orbit of a radius 7.87 times 10 to the 6 meters around the Earth, but in opposite senses of rotation, therefore in a collision course. A, find the total mechanical energy of the two satellites and Earth system before the collision, and B, if the collision is completely inelastic, so the record remains in one piece of tangled material of mass 2m, find the total mechanical energy after the collision, and C, just after the collision, is the wreckage falling towards Earth's center or orbiting around it? So there's three parts to this question, and I've made a sketch of it. It kind of reminds me of the movie Gravity, where there's a collision which creates some space debris that causes problems on the International Space Station. Regardless, here's the sketch. I've copied it here. We can see kind of the orbital path of satellite B around the circle, and we can see the orbital path also of satellite A, which is here around the circle. And from previous work done in class, and you should be able to derive some of this, this is the gravitational potential energy for an object can be given by negative G, big M, little m over R. That comes from dealing with an object at infinity having no gravitational potential energy. So as it approaches infinity, R increases and the value approaches 0. However, we did derive in class the idea that an object's kinetic energy, K, can be written as G big M little m over 2R. So we can see then that the object's total energy, E, would be given by U plus K. And in this case, the result of that would be then negative G big M little m over 2R. And this is only appropriate, this specific formula for the kinetic energy of an object in a stable circular orbit. It has to be in a circular orbit here. Circular orbit. So if it's not in a circular orbit, we can't use this, and then therefore that formula for total energy doesn't work. So a couple of things. Number one, you need to keep in mind that formula for kinetic energy is unique to objects moving in circular orbit. And then secondly, you have to be able to derive that. These aren't formulas that are given to you on your yellow equation sheet. So it should be something that you are prepared to derive should you have to. I'm ready to just, at this point, plug some numbers in and then simply say that the total energy in the system is going to be equal to negative G M big M little m, where big M is the mass of the Earth and little m is the mass of the satellite, over 2R, but we're going to multiply that by 2 because there are two objects. And so therefore the 2's go away, and I just have negative G M, the mass of the satellite, mass of the Earth, and the mass of the Earth, big M here, is going to be 5.98 times 10 to the 24th kilograms, times 10 to the 24th kg. And then that's a constant that'd be given to you. And then I would need to know 6.7 times 10 to the negative 11. I'm going to just kind of abbreviate it there, e to the minus 11. And that's going to be in Newton meters squared over kilograms squared. Those are those units that should be going over there. And then I need to divide it by the radius, which is a 7.87 times 10 to the 6 meters that was given to me in the problem. And once I've done that, I should get an answer that is negative because there's a negative sign here in front of this. And I'm running out of space, so I'm just going to kind of move this a little bit. And I get a final energy of both satellites, total energy, not gravitational potential energy, not kinetic, but both of those, negative 6.33 times 10 to the 9th joules. So that's my answer to part A. I'm going to go ahead and keep moving in part B. um, it says that the speed of the wreckage will be 0 immediately after the collision, so it has no kinetic energy. And we're going to replace now m with 2m. So basically I can say that the energy E is going to be equal to negative g mass of the Earth times 2m, because there are two of these objects. I'm going to divide that by 2r. So plugging these numbers in, that's going to be negative, and then I'm going to multiply it by 6.67 times 10 to the negative 11 Newton meter squared over kilogram squared. And then I'm going to multiply that by mass of the Earth, 5.98 times 10 to the 24 kg. And I'm going to multiply that by 2m, which is going to be 250 kilograms. And I'm going to divide the whole thing by twice the radius, 2 times 7.87 times 10 to the negative, 7.87 times 10 to the 6th meters. And when I run that through my calculator, I can say then that the total energy is negative 6.33 times 10 to the 9th joules. So we can see here that the number hasn't changed. And then the final question goes on to ask what happens to it. So immediately it has no velocity. So if this is, the Earth system and the satellites have now crashed and are combined, they're not moving side to side at all. There's no kinetic energy, and so therefore they're only under the influence of gravity, and they will accelerate directly towards Earth's center.